Friends, here we are going to discuss the next topic of the Unit 2 of Paper 1, interference. Interference is nothing but, here to remember the definition. Interference is nothing but the phenomena of redistribution of the light energy due to the superposition of the light waves from two or more coherent sources in the form of the maximum minima of the intensity is known as the interference. Okay, maximum intensity is nothing but the brightness, and the minimum intensity is nothing but the darkness, that you have to remember. When the waves interfere with each other in the phase, the maximum of the intensity is produced and point appears bright. This is called as a constructive interference, that may come for the MCQs. And the destructive interference, when the waves interfere with each other out of phase. In phase, constructive; out of phase, destructive. With the and the minimum intensity is produced and the point appears dark, it's called as the destructive interference. Part difference for the that particular constructive interference, delta is equal to n lambda, where n is equal to 0 1 2 3 4 5, and a part difference for the destructive interference is delta is equal to 2n plus 1 lambda by 2, that you have to remember. It may come for the MCQ. To get the steady interference pattern, the two sources should be coherent and monochromatic. The sources should be narrow and the amplitude of the waves should be same. Then the Stokes law. What is about the Stokes law? The process of the reflection affects the phase of a light wave of wavelength lambda. When a light is reflected at the surface of an optically denser medium, it suffers a phase change of 180 or pi radian. It is equivalent to change in the part difference of lambda by 2. When the reflection takes place from the surface of the rarer medium, no phase change is observed. Phase change on reflection. When light is incident on the surface, a part of the light gets reflected while remaining may get transmitted or absorbed. Let R be the reflection coefficient according to Fresnel's theory for normal incidence, that R is equal to mu1 minus mu2 divided by mu1 plus mu2. R is positive when mu2 is greater than mu1. It implies that mu2 is lesser than mu1. It implies that the oscillation in the incident and the reflected waves occurs in the same phase. When mu2 is greater than mu1, then R is negative, implies that the oscillation is in the incident and the reflected wave are opposite in phase. That you have to remember because MCQ will be there based on this particular thing. Then interference in the thin film due to the reflected light. Here you can see how the interference occurs. We are not going in this particular theoretical part, or say this particular derivations. Here you have to remember this optical part difference between the two rays emerging from the upper surface of the thin film is given by delta is equal to 2 mu t cos r. But when the light is reflected from the surface of an optically denser medium, a phase change of pi radian, that is a path difference of lambda by 2 occurs. Hence the expression for the path difference delta between the two rays is given by delta is equal to 2 mu t cos r, okay, minus lambda by 2. Condition for brightness here given. You can remember, this may come for the MCQ purpose. 2 mu t cos r is equal to n plus 1 lambda by 2. This is for the constructive interference, and for the destructive interference, or say for the darkness, there will be the 2 mu t cos r is equal to n plus 1 lambda. Okay. Interference in the film due to the transmitted light. Here this r again, the delta is equal to 2 mu t cos r. This is the equation for this part difference, and then for the conditions for the constructive and the destructive interference are these. We are not going in detail of this particular thing. The color of the thin film. When the white light is incident on the thin film, okay, light reflecting from it will not have the color when whose wavelength satisfies the condition for the darkness, that is 2 mu t cos r is equal to n lambda, and thus the film appears colored, and the color depend on the thickness t and the angle of the inclination r. If r and t are constant, the color is uniform. In the case of oil or on water, we see different colors as both are both R and T vary. That's why we got this particular thing. This reason is that why the when oil on the water is there, we see the different colors. That different colors you observe. You can see on the road when the oil is fall is there. Okay, if water is there and the oil is fall on that particular thing, you can observe the different color. This is due to the variation in the R and the T. Fringes in the waist shape film. Waist shape film. These are called as the fringes. And this is a Newton rings experiment is there. The fringes produced with the monochromatic light are concentrated circular fringes of uniform thickness with the point of contact as a center. These circular fringes are called as the Newton rings. That may come for the MCQ. That's why I taken this. Okay. Here again these things are there. You can see and you can understand what is the important part that I am going to explain you. Here the Newton rings has been shown and the equation for the Newton rings is shown there, how that derived. Okay, you can derive the thickness of that ring, you can derive the intensity of that ring, then the diameter of the ring. I said here you can see diameter of the ring, determination of the wavelength. These are things are possible by doing the Newton's experiment, Newton's rings experiment. Now we have to talk regarding. Yeah, again the wavelength can be determined. How the wavelength can be determined, that is given. Determination of the refractive index of a liquid. This rings experiment, Newton rings experiment, is also applicable for the determination of the refractive index of the liquid. This is again which is a very detailed one. We are not going in such a detail. Okay, here these are the numericals solved based on this particular topic. Solved numericals are there. You can see the solved numericals are here. So many numericals are solved there. These are the questions, variable question based on this particular thing. We will talk about this Newton ring experiment. Circular concentric fringes obtained due to the light phenomena. What is that? Interference. When the light is reflected at the surface of an optically denser medium, it suffers a phase change of 180 degree. That you have to remember. Pi is nothing but a 180 degree. Likewise, the MCQs will be there. You have to go through this part. Here we will stop. Here the unit 2 of the paper 1 has been finished. Thank you.